How are you doing? Welcome to another LarsLive number 8. I was just looking at the playlist. This is the 45th of these videos where I'm just trying to answer some of my emails. Hopefully this is somewhat beneficial to you guys. This is actually Saturday I'm recording this. Because when you're watching this, I will be at my daughter's high school graduation ceremony. So had to do another Saturday recording, but still the same thing. Gonna just run through a bunch of emails from you guys, Lars.Christensen@autodesk.com, and hopefully some of this is valuable to you, and you can use that in your endeavor with Fusion 360. That's the goal. Hope you're doing well. Life is good. Let's get into it. So, the first email is from Hans-Peter Christensen. Sounds very Danish, huh? Hi Lars, love your videos. Thank you so much. And can you recreate an interactive version of a Hyperboloid? See, if you send me something and I cannot pronounce it, Hyperboloid. Let's get into this. Because I actually, with this, we also got a Wikipedia page. And so can we create something that is something like this inside of Fusion 360? Hans-Peter, I don't know why you want to do this. And I probably have to admit that, when in high school they were going over this, I was probably not paying attention. But pretty much Hyperboloid, I don't know, however you pronounce it. Somewhat we can do something inside of Fusion. Now, Hans-Peter has actually attempted this to do it himself. Just a quick image he sent me of trying to create something like that. Now, I think where you're getting a little bit caught up is using components and bodies, because this is again where we are stretching Fusion to what Fusion is really meant to do. Because what Mechanical CAD, Inventor, Fusion, SolidWorks, what they're really good at is to give you the end result. The end product that you need to do. So as soon as you start trying to do kind of like animations, or there's other software that can do that. For example, when we're looking at this image of this thing here spinning around, then that's not done in Mechanical CAD software. That's done in some kind of other animation. But anyways, let's at least jump into this and let me give it, remember, I didn't pay attention to this in school, but let's talk a little bit about it. So I'm going to start out with creating a sketch. And on the face here, C for circle. And let's make this 100 millimeters. And that sketch. So now we have a sketch down here. I'm going to go ahead and do a offset plane. And let's make that, drag this up on the arrow. Let's make it like 150. So that's up there. Let's create another sketch on that. C for circle, and kind of do the same thing, right? I made it 100. Okay. So now we have these two circles. Now, so I just wanted my point about making the end result, so something that looks like this, Hyperboloid, or however you pronounce it, of one sheet. We could do something like that inside of Fusion very easily, in the sense that now if we went in and we created another sketch, let's finish this sketch, let's create a third sketch. I'm just going to sketch on the side view here, and let's do a P for project. Let's project this circle and this circle here, hit OK, so we kind of get the endpoints. And we could do something like a spline from here, and then I'm going to make a midpoint somewhere over here, and then an endpoint there. So now we have a 3-point spline, D for dimension, and we could place this midpoint here at the middle between our planes. So this is going to be in the middle of our two big circles. And then we could also kind of define the the width of it here. So let's make that 15, and that is now kind of like fully defined spline sitting like that. Now if we went now and did an O for offset on that, and let's bring it in like minus a couple of millimeters maybe. Now if we went in and did a revolve of this around the center line, hit OK, then as far as I know, without spending too much, remember, you're hitting the limit of my brain cells here. That is a hyperboloid or whatever, however you pronounce it, here, and I believe so. And down in the comment area, if you disagree. Now to Hans Christensen, or Hans Peter Christensen wants a interactive one, and I think from my perspective, again, Mechanical CAD is really meant to give you the end result. So if this is one of those, then this is the end result. But you could, in sense, if we just let's delete the last two things. So we just have the circles. If we go into the first circle, and we use something like a point, let's go snap a point to the circle here, and let's give it a dimension. And let's make that something, doesn't matter. We make it 35, remember that? Let's go into so there's that point. Let's go to the top circle and do the same thing. Let's do a point, but let's make sure we place that somewhere else and give that a dimension. Like that. And let's just, for easy, make that 45. Finish that. So now we kind of have these two different points. And now if we said, let's create another sketch on this face here, and if you have that 3D sketch area on there, if we go in here and we create a line just out in space, you could use the coincident to snap this one to each of these points, right? And now you have a line that is interactive with those dimensions that we used to where to place these points. And I'm not quite sure. I honestly, I don't even know if this, and don't forget we have parameters, so we could now start being creative and kind of drive these two, this 35 and this 45 with another, with parameters, and somehow make them interactive. But looking online, it looks like that this, if you had some other ones of these, you could start creating surfaces between them, and that may be how you kind of do that. So I feel like that I'm hitting somewhere in the middle, right? Like when I'm looking at this animation here, trying to understand this, it looks like that the top point is stationary and the bottom point is kind of like spinning around. So if I go in and and again, hence Peter, you call my bluff. So if we go in to the bottom one, what we could do was we can go into that bottom sketch right there, right click, and say show dimension, so we can see the dimension. So there is our 35, and now if we started changing that, to 15, we are kind of getting, that that movement, right, to whatever that is. So in that sense, hope that makes sense. I hope that was not a waste of your time. Me just trying to answer some emails. If you like it, thumbs up. If you don't, be honest, thumbs down. I love your comments. And if you have something to add to this, do it. Put it in there. If you haven't subscribed to the channel, love if you do that too. My laptop just went to sleep. Sorry about that. So that means I've talked too long. So yeah, Hans Peter Christensen. I'm sorry, I keep on messing up your name. I hope that was useful. All right, let's jump to the next one. The next one is from Yaivel. Yaivel, I hope that's say your name right. Dear Lars, I want to make a ring with a pattern in it. Can I somehow do unfold to it and then draw and extrude? Please explain to me how. And it doesn't have to be in a live stream. Well, It's definitely on video. Yes, let's jump into to that and take a look at that. Now, let's just move on from our Hyperboloid or whatever, how you pronounce that. So if we talk about unflattening anything, then we're normally looking at sheet metal. So let's go into the sheet metal workspace up here. And there's a little bit of a trick if you're trying to make a ring in using sheet metal, in the sense that it can't be fully enclosed when you're doing all the fold and unfold. Now you could potentially do that afterwards, but I'm gonna go in and create a sketch on one of these faces and C for circle. And I honestly don't know how big a ring is. Let's make it 25 millimeters. Like this here. Now the trick, like I said, is that it cannot be fully round and be flattened. There's a couple of, this is kind of like a little tips and tricks here. So create a line vertical up to snap into there. And then I'm going to create a line out here in a little bit of an angle. So D for dimension. And let's make this, oops, I don't want to do it on that side. That's stupid. I want it between there. Let's make it like, I don't know, it doesn't really matter. It just has to be a little bit of a gap. I'm making it 2 degrees up there, and then I'm going to break this, and you can do that in the modify. There's a trim function. So I'm going to break this out. See that? So now it's broken like that. Now, when we go in to sheet metal to do a flange, make sure that you select not the face, but actually the edge here. And then you kind of get, you get this section out here. And I'm a little bit, this might be, I'm not sure sizes are right. But, but we have this gap here, but it's still not good enough. We need, this is a little like, we need a little flat piece to be able to flatten this. So what I'm going to do is I'm going to go in and do an extrude. And I'm going to select that face I used before. And it can be tiny, so 0.1. Like, it just needs a little bit of a flat in there. That doesn't really even matter. And of course, if you're producing this in real life, if you wanted to solder it in the end to make it a full ring, of course you can do that. But what we can do now is if we go into the modify drop down, we have an unfold. And if we select that flat little face there, and we can say unfold all bends, then it becomes flat. Hit OK, and now it's flat. And notice that there is a refold button we're going to use up here in a second after we now put our pattern in. So now we can go ahead and we can pattern, we can pattern whatever we want. So I'm going to go ahead here and start a sketch, and C for circle. I'm going to do a line, L for line from the midpoint to here. And C for circle. I'm just going to draw a circle here. Let's make it like 6. And maybe we drag it in a little bit. D for dimension. We could put I really don't bother fully define everything when I'm doing this, but just for the rule of it, let's make this 5. And then we could do like a Q for press pull. We could make a cut through here. Like this, and then I would probably could use something like pattern. Now notice that we are in sheet metal, so notice that the pattern is not really in here. You notice that? Pattern is not in here. Well, you can always jump over to your solid workspace, even though that we are working with a sheet metal part. You can incorporate these, so this is really handy. So just rectangular pattern. I'm just going to select this face. I'm going to select this as my direction. And then we can start doing how many we want. And I did cover in a couple of videos ago how we can control length and stuff like that. So I'm not going to worry about that here. Let's make 8 of them. Hit OK, and now we have those. And then we can just jump back to sheet metal and say unfold, and then it will fold it back with whatever that shape was that we decided to put in there. So that's how you can do that ring. Now, if this was a real ring, you're modeling it up, like I said, you probably want to solder this up. But this is how we can model it. And if I go back down on the timeline, then it's flat. Go forward, then it's bent. Ha! Useful? I hope so. Cool trick, right? Down if you don't like it. It's okay. Comments? Love them. And if you haven't subscribed to the channel, I would truly appreciate that. that was as in 2016, two teenager. That was 2. All right, the next one here is from Michael, and this one is a good one. Michael ended up sending me like 3 or 4 emails going on this project that he's working on trying to make a motorcycle frame. And what he sent me was actually that he had watched a, oh yeah, that was the first video with the hyper, how do you pronounce this? All right, never mind. So Jacob Anderson, definitely check this guy out. Has a bunch of videos. He does a video on how to create a chopper frame. You see this cool chopper frame? And I will say that, so Jacob, thank you for sharing your content. He does have a Udemy course, so you can actually get deep into this whole tutorial. I haven't watched Jacob's tutorial, but one of the things, and he does some really nice rendering here in the end too, so nice work, Jacob. But the question I'm getting from Michael is that early on, what Jacob does to create these frames is that he's using surfacing sketches to create kind of like this development here. And I don't want to steal anything away from Jacob. Definitely go and check out his channel, Jacob Anderson, for this. But I can maybe just show a little bit about what the principles are of what Jacob is doing here. Really, what it is, and it's I would call it a little bit old school. And it's using surfaces to create compound 3D sketches. So it's funny, if we go into Fusion, that somebody just emailed me earlier, or messaged me on Facebook or somewhere on social, reached out to me and was asking me about the surfacing command. I was kind of like, why would I even bother trying to figure surfaces out? And my comment is like, I agree. Like with the solid workspace, especially with the sculpt workspace involved here, using surfaces is really not that common anymore. However, there is some things about surfacing, and again, like I said, it's kind of old school, but there's certain things you can do with it that is actually pretty cool. So this is what we're gonna jump in here with, hopefully inspire you guys to do a little bit something like what Jacob is doing here, to utilize to make a bike frame or sweep, kind of like a development sweep like this. So the idea is, and again, if you're brand new to Fusion, I don't want to scare you away at all, because surfacing used to be considered high level or complex, but surfacing is really not that complex. It's just when we do, let me just do something here and waste a little bit of time. If I go in right now and I create a sketch in the solid space, and I create a sketch here, and I'm gonna hit a 2-point rectangle, and let's make it 50 by 50. Okay. And let's extrude it. So we're gonna go back in and do an extrusion, and let's select it here and let's make it 50. So now we have a sketch and we have an extrusion. Now, hopefully, most of you guys out there feel pretty comfortable with this, right? Like, yeah, got this. If you're new to Fusion, even then, I hope that this makes you feel pretty good. A sketch and an extrusion. Now, I'm just gonna do this just to show really how CAD works, mechanical CAD works. And you let me know in the comments area if this is good. If I open up a new document, so blank document, instead I'm going to go into the surfacing command. I'm going to do the same thing. I'm going to open a sketch, and I'm going to do a 2-point rectangle, and I'm going to do 50 by 50. Same thing. Now, instead of going over to the solid workspace and hit extrude, I'm going to be in the surface workspace, and I'm going to hit extrude. Okay? Select that same area and go 50 up. Now, when I hit OK to this, you will see that we have something that is very close to our solid model, but it's just surfaces. It's just a shell. So the biggest thing about surfacing is that it's just shells, non-thick, paper-thin, no thickness walls. But it actually means that if I go in now on the surface body, and I go in and say I'm going to create a patch on this top face, and do the same thing on the bottom, like this, now we actually kind of have the same cube as you see here. But the difference is that this is solid. This surface body is still hollow inside of it. We just kind of put the shells around it. Now, what we could do was we could select the whole thing, and we could go in and say stitch. And when we go in and stitch it, we actually have the option to turn it into, select the whole thing here. Just want to make sure I select it all. That now it will become a solid body. Okay? So right now in CAD, these two are identical. Got it? Because it turned into a solid. But notice how many operations this took down here versus this. This took 2, this took 3. But this is actually what the software is doing in the background. So when you are executing this simple one, the solid is actually doing all these stuff. It's extruding up and it's being like, okay, let me close each end and then let me see if I can turn it into a solid. So this is what the software is doing in the background. So I hope this kind of, if you are fairly new to Fusion or to mechanical CAD, just so you know, this is what the software does in the background. All right, sorry, I got a little, I get carried away. So let's go into the motorcycle frame that Jacob did and Michael is trying to do. So what Jacob does is he's actually using surfacing to create a development that he then can use to turn it into a solid frame. So if I go in and I say I'm going to create a sketch here, and again, I don't want to steal Jacob's thunder because Jacob has his own channel and he's doing, sharing his thing. But just to give you a little bit of a taste of it, and hopefully enough, Michael, for you to kind of maybe just attack this on your own or get a little bit further. So I'm going to do a center slot, what is a standard sketch tool we have, right? And let me just make this like 120 like this. And let me just extrude this. Now again, I'm going to extrude it as a surface, just like I did before. So it's really just the shell. Now, if I go in and I now open a new sketch, so forget about this thing right now. Actually, we could hide it if we wanted to. Open a new sketch on the side view. Well, actually, I'm going to turn it back on so I can see what I'm doing. And let's draw a line from the center to about the same point where this finished here. Go a little bit past it, just because. So now we have a new line. That line is sitting right on the center here. And then we could go in and do something like a 3-point arc, for example. And just draw an arc up like this here. And I'm actually going to make it be tangent. Now, what I could be tempted to do now is to say, all right, let me P for project and select this so I get kind of the end point here. And let's make these two vertical, right? I'm still leaving some things underdefined. But really what we have right now, if I finish this, is that we have kind of created this shape. If we go and we then extrude that out, so we're making 2 different extrusions. So let's select this. Oh, extrude that out. And let's just go one side. You now see how these 2 surface bodies are kind of interacting, or, they're interfering with each other right here, right? We got the 2 surface bodies. They're kind of interfering with one another. Now, because it's surface bodies, if I go in and I trim them, click trim, and I select this, the first one we did, and I trim that with the second one we did, and hit OK, then you will see the second one kind of got shortened. But now we have this development curve right here from where those 2 were cut short, right? Where they're intersecting. Now we could use that curve to create that compound development. So if I go in and open, so now I'm going to just hide these 2 for a second. Well, let's leave. No, I'm not going to do that. Sorry. Let's go in and open a new sketch on that same face we did before. And let's hit P for project and steal that edge. And start a circle on that face. How big we want to make it? 10 millimeters. So now we have a circle. Now we could use traditional sweep command and say that this is my profile, and then my path is going to be that edge. I can now select that edge. I'm just going to turn off chain selection. So I select each segment. And I'm not selecting that edge of it. Well, that's interesting. I can't select that end there. Hang on. So we got that, and we got that development there. I'm not sure why I can't select that edge. Oh, maybe it's because it's stopping right there. Hang on a second. Hang on a second. Let's go back and try again. Not revolve. Let's go in and do a sweep. It was me. So we're going to turn off chain selection. We're going to select the profile, and then the path is this edge. See, what happened was that there's actually a bitty sliver down there because of my development. That edge and that edge. That's what I wanted. And hit OK to that. And if I turn these surface bodies off, now look what I got. I got a using that development to do this. So now you could go in and do something like a mirror. And if we select the bodies, this body, and we mirror that over this plane here. And now we have maybe not a motorcycle frame, but we kind of got that, we somewhat got that development there. So utilizing these surfaces can help you create compound angles like that. And again, if you're looking at Jacob's video, what I surely would recommend, you can see that he's actually, I think he's using more surfaces than just 2. So I just use 2, but you can use 3, and you can become better and closer onto those. Hope that was useful. If it was, do me a favor, hit the thumbs up. If it wasn't, thumbs down. It's okay. Love your comments, and if you haven't subscribed to the channel, I would truly appreciate that. This is just me trying to get through some of my emails to make sure that I answer as many of your guys' questions as possible. Hopefully, it's adding a little bit of value to your day. Next one is from Samir. Mohammed Samir is a CSE student and is trying to make a humanoid robot. So like a robot that looks like a human, and is asking if I have any tutorials about doing any kind of that type of robot. I don't. I really don't. I think I'm a very mechanical type of guy, like an old machinist of trade. I have done, so if you do go, so one thing, if you're completely green to Fusion, I would recommend you could go out to Google, and we could jump into to YouTube. That would be one thing to do. Go to YouTube. There we go. And let's go to my, so you could search for Lars Christensen and get to my channel. And if you go to the playlist, there is the LarsLives. And I normally just click on this little link up here that will take me out to the whole list of the 198 that was done in here, of all these. But one of the things I did do in here was I did one on sculpt. The easiest thing to do is Control F for searching, and if you do sculpt in here, there's an intro to a sculpting tutorial where I'm modeling up a spoon, but it's far from a robot. I get that, but hopefully this can kind of get you started, because that's definitely the space you want to be in. Also, just so you know, if you search on YouTube and you search Autodesk, and I think it was called Robo Boy, maybe. I thought it was called Robo Boy, not Robot Boy. I could be wrong. That is definitely not what I'm looking for. This one here, Roboy, it's called. just know that my good friend, and he actually also have, I should introduce you to another. So this was a project. Now I'm jumping all over the place. That Roboid that was done. Steve Hooper, he's the GM for Fusion 360. So now you know how he looks like. But this whole robot here, interactive robot, I thought that was maybe somewhere in here. It showed the whole thing. There's the kind of like a part of it. But this guy, his YouTube channel, and Mickey has some really good videos. So that's worth checking out. All right. So if you're German and you're looking for some cool Fusion 360 videos, Mickey Wakefield is definitely worth checking out. All right. So we got into some good stuff. We've done some biker frames. We've done some hyperboloids or rings and things like that. Let's jump to the next one. The next one is from I'm not sure this is from. This is somebody whose email is copy paste. So hi Lars, we in the lab we have a Haas 20 ST's 20. So that's a 3+1 lathe. But we couldn't find a solution on how to machine a screw via Fusion 360. Sent me an image. Looks like this. As far as I know, is not supported with Fusion 360. As far as I know, and I'm saying that a little hesitant, and I think part of it, Saturday morning, had to need some coffee. Part of it is because of rotary tables that spins around. A lot of them, at least in the olden days, needed to rewind. So it become complicated when they got to 360 degrees, and then they have to go all the way around, but then they gotta go reverse again. However, I'm saying this a little hesitant because I haven't looked deeply into this, but I'm wondering though, inside of Fusion, in the manufacturing, and maybe some camp specialists can jump in, I would think that the multi-axis toolpath might actually be able to do it if you modeled up the helix, so the center portion of where you wanted your cutter to drive. Then I think it might actually be, and you're post supported, then I actually think it might be possible, but I'm not 100% sure. Not 100% sure. Maybe not. Yeah, not a great answer, but the best I got. All right, let's move on. Another cam one. Next one is from Christopher. Love your videos. Thank you, man. You sometimes answer questions that I didn't know I had. Right? See attached picture. That's a picture. Picture from Christopher. There we go. Let me expand that up a little bit. Question from Christopher. Why do I always get these tool marks when cutting out a part? Is there a cam setting so I don't have to do so much sanding? So I'm looking at this, and you guys maybe also be sticking your nose on the screen here. I'm assuming, Christopher, we're talking about these two vertical lines here, and not. It looks like there might also be some. It could be gouges. I don't know, but somewhat also looks like it's the wood. If this is the ones that you're talking about, then there's something up with your tool being possibly hanging out too far, and your feet and speeds are not great, and it's whittling around in there maybe. I'm not sure. But if it is these two here, there could be a couple of different things. First of all, you're saying that when you are cutting out a part. So question is, if you are cutting around and you let your cutter sit there for a while, it could do a dwelling, but it could also be a lead in, lead out. So let's talk a little bit about that. Let me just go in here. I'm gonna go in and do a S key, and let's do a center rectangle. Draw something up here. Q for press pull. I'm not sure how big I'm making this part. Let's go into manufacture and do a setup, and go in and do a contour toolpath. By the way, let's first select the cutter. So there's a couple of different things. I'm not sure. Oh, this color's big enough. Couple of different things. So we're going to select this bottom edge here. Be aware of that if you're cutting something out of a sheet, that you can insert tabs in here in the console toolpath. You need to know about that for sure, Christopher, because if you have a problem where when you're trying to cut the part out, so there's a couple of different things. First of all, if you have it in a sheet and you're kind of like just machining around and you let the cutter sit there, then the cutter can kind of just sit there and cut still, like feather cutting or something like that, if it's just sitting still and it's not moving around. Another thing could be that if you're cutting all the way through, that when you're cutting the last piece through, that your piece kinks a little bit, and that makes the cutter kind of gouge into the material, right? Now, if you're using these tabs, you can avoid that in the sense that you can machine everything around, and then you can just go in with a little saw or something, and you can just, saw those tabs out, and then you only have to sand those areas. But the other thing, let me just get out of the toolpath for a second. Another little trick that I used to do a lot in steel, and I probably would do the same thing in wood too, is if you go in and chamfer your corners right here, in case you've never tried this, just give it a little bit of a chamfer, like, I don't know what a little bit is here, 0.25 or something. If you're just breaking it in your model, then when you're machining around this part, then you don't have to think about this corner being sharp. You can put a nice little chamfer on that. That's a nice little tip. Definitely if you're doing steel, that's a if you've never done that, do that to all your outside things, and you're gonna love me for that. All right, let's go back into that toolpath again. The other thing I want to show you, select the tool again, select bottom edge, hit OK. The other thing I want to show you is it could also be where your tool enters and exits the material, that you get kind of, whoops, wrong image. We already covered that. Where you get that marks when your cutter enters and exits the material in there, because what many times happens is that the cutter comes in and it's cutting a lot of material, and the servo motor on your mill kind of comes in and it's got to do this arc, and it sucks the cutter in a little bit. What I have done to solve this problem is I would never start on the face, because it's just hated this machining a piece of steel and have that little sucking mark in the center. So what I always have done is right click on your operation, go to the last tab, and down here you can change an entry point. Last tab all the way in the bottom, and just select that edge right there, or that point right there, and hit OK. And now your lead in and lead out is happening right on that edge where nobody's gonna see it. Genius, right? So that's another way to get that mark away. And then lastly is you could actually also run into a problem, depending on your machine, where when your machine is changing direction, so you're machining around the part, where it's changing directions that your servo motors can't keep up. Especially if you're cutting something like wood, where you're going a pretty fast feed rate, you're asking a lot of your machine. You're asking it to go, the servo motor on your Y direction is going, and then suddenly, like, boom, you want that to stop, and you want the X-axis to start going in the other direction. And you might have a little bit of delay between the calculations of your computer to the motors need to slow down and start up. One last trick is if you go into your 2D contour, go to the cut tab, there is actually in here a outer corner mode that they put in here, where you can choose to say keep sharp corner with a loop. And if you do that, you will actually see that the cutter is literally going to come on and off. If I simulate this, it might be easier to see. the cutter is literally going to come on and off the part. See that? So what it does here is it's literally going in the Y direction, and then it walks off the part and comes back again with the Y direction, with the X direction. And of course, this is a little bit longer tool path, but if you have, I mean, I've done this in real life, if you had a very accurate part that you had to do, or if your machine just can't handle it. That's some cool tricks right there. I hope that was useful, Christopher. Hopefully. All right. Next one here. Good day, sir. Hello to you. Need your help with Fusion. And I can't find a solution. My Fusion sketch plane is black in color. Please, how do I change it to a white sketch plane? That sucks. It's just me trying to get through some emails here. So I don't have a screenshot, but what I'm assuming is happening. Here's a little tip. If you didn't know, just go down to the display settings down here and go into environment, and you might have changed this to dark sky. Look what's happening. So now if you go to do anything, you go to extrude something, then you will see that everything have kind of changed the view. Going to extrude something up here, you will see that everything have become dark. So you can change different environments down here. If you go to gray room, everything gets a little bit more gray. If you go to blue, then it becomes blue. And photo booth is the one we normally use. So that might be the one you want to go and just make sure that you got the photo booth in here. So that's a neat little trick. What you can do is, and you might have to start Fusion all over, but so somebody might be saying, why the heck would you ever have this as dark sky? Well, you know what, honestly, when I used to work on the shop floor, our computer room was like a dark room, and have these bright white screens in your face was actually not that great. So what you could do is you could switch it to the dark, and then if you go to your settings and you go into preferences, in here you can go to, I think you want to go into your materials, and if you change your material to something other than metal, but like something that has a color to it, then when you are extruding inside of this mode, for whatever reason, whatever you're working on, you can change the color of this part to be, red or blue or something else, so it doesn't become gray on gray. But I think that's what you might have done by mistake, is to go down, click on the little TV screen, go to environment, and go and change that to photo booth, and you should be good back again. Hope that was useful. That was a quick little one. Thumbs up if you like it. Thumbs down if you don't. But sometimes people forget about those menus down there. All right. Next one is from Cassin, who's coming out of Germany. Greatly appreciate your tutorials. Well, thank you so much for watching. I missed a point. And so this has to do with, on a round part, placing characters on a completely round pipe. And I'm not quite sure what you mean about round characters around a round pipe. You could be talking about going in, if we did something like something round, C for circle, and let's just extrude this pipe out here. If you wanted to do some characters that's coming out of this part, you could open up a sketch, and let me select the side face here. And if I did something like a circle, and let's extrude that out, and not making it a cut, make a new body. I'd like to make a weapon out of this, I guess. And turn the how about that? So now we kind of have this sticking out of here. If you want it around, you could use the circular pattern tool, right? And say I want to I want that face, and I want that around that edge. And then you could get those, whoops. I think this is multiple bodies. Hang on. What if I don't do it as two different bodies? Edit that. Not a new body, but we're gonna join it. Okay, there we go. Then you could use that circular feature to get the circular pattern to get something round there. It might actually go back to our second one here. We could have done the same thing with this one if we go back and edit this one right here, and instead of making that a cut, we could make that a something like that too, and we could have something from a ring from I don't know, what is that, a ring from 1990 or something like that, punk culture. So there's a couple of different ways you can get round characters around something. I'm not really sure if this is helpful, but yeah, I would say that probably using the pattern feature is probably the easy one. Send me a screenshot if you want me to take another look at that. Hope that was somewhat useful. Next one is from Brian Lewis. We've been going for about an hour, a little under an hour here. All right. I was wondering how to probably model joints and animations in regard to a typical mold slide action. While mold is closing, the angular pin that travels on a mold component, so a slider on a mold. So if you're not into molds, this might be a little, but on a plastic injection mold, if you need to make a feature from the side on it, then I'm looking for something in my office that has that. Then you have a slider going in and out of it. And how to do that. So how do you model that up so it works with the slider? All right, let me see if I can do this without becoming too complicated. So I just want to point out though that if you do go out to Fusion and you do a Fusion 360 and you do mold, I did a couple of videos. This tutorial right here, I did a plastic injection mold in this tutorial on this part. Now, this part did not have a slider in it, but it might be a good one to watch, Brian, if you haven't watched any of them. So, actually, to figure out slides in a mold, and this is how I would do it, you would never worry about the movement per se, because the movement is what you're concentrating on is the mold closing, and then everything else will come from that. Let me try to show what I'm talking about. So I'm going to use the top-down approach here. So let me just go ahead here and let's draw up something. Let's make this mold 20 by 250. That's a mold plate right there. Let's make a midpoint from here to here. So that's the bottom mold plate right there. Let's draw up an insert. I'm going to open up a new sketch on here. This could actually all be done in the same sketch. Let's do it all in one sketch. Edit the first sketch. So there's a bottom mold plate. I'm going to draw up my my slider from the side view. So here's the slider going over. It's going to have an angle kind of going down like that. And let's just put some dimensions on it, Brian. I'm going to make this 25. Let's create an angle from here to here. That's going to be where when it's closed, right? It's gonna fit that in there. And let's just do 15. And then we probably need some kind of other dimension here, 50. So that's our side view in. Bottom, the cab or the core side sitting, the core plate with the slider on it here. And then we're gonna have a mold plate on top of it. So that is going to be that is going to be probably this actually the same as the top one. So default dimension, place this dimension out here, make that those two the same, and let's make this and this. Oh. This line. Hey, why wouldn't you make? There you go. Make that there, and let's just make these two equal lengths right there, and that would probably be sitting right. That would be sitting right down there in a closed space. Let's just close this off here. So the top, what you're seeing up here is the top mold plate. There's the insert that is sliding, and there's the bottom plate, and then you have a pin, and that's what you're talking about, I think, trying to calculate out. Now that pin would probably be starting up here somewhere, coming down to, I would probably just draw it down to somewhere on this part here. Make that parallel to your shotting angle, and give that some kind of a, that's going to be some kind of an angle between this, 25 maybe. So this closing surface here and this one is the same. Now I know that right now this might seem a little bit confusing what I'm trying to do, but if you draw everything up as it's closed, then in real life it really will work. So let me just go ahead and put a link to this one here. Let's try to make it 55. So that will go down a little bit further. So let me now go in and actually utilize this text, because somebody right now is like, what the heck are you doing? I'm going to go ahead and create a new component. I'm going to call this one slow, left click. I'm going to call this bottom plate. And hopefully this starts to make sense. For the bottom plate, I'm going to extrude that one out. And I'm going to use that bottom. This is my bottom plate here. I'm going to do everything symmetrical. So there is the bottom plate. That's going to make the sketch go away. So turn that back on. Let's do the insert. So let's right click up here and do new component. And that's going to be our slider. So we're going to call that one slider insert. Right? And let's extrude that one out. That's going to be these two sections here. Symmetrical. And normally they're sitting in it, like they would have like sliders on it and things like that. But I hope that this makes a printable. Then we're going to do the top plate. Right click new component. And slow left click on that. And call that the top plate. Like that. And extrude that out. And for this, we're going to select these three here. Make that symmetrical. So there's the plate kind of going out. Of course, that's going to be the same, probably the same size as the bottom one. So what we have right now is we have the bottom plate, we have the insert, and we have the top plate. So if we go up here and make this active up here, you can kind of see how we have these sitting. So the slider here can go back and out this way. In a closed mold, this surface right here is locking on that insert, so it can't open. Now, where I think that you get to with the point here is that, okay, that's all great, but there's a pin, and how does that place? Well, that pin is normally cutting right through. That's that line I created right there. So what you could do is you could go ahead and create another component and call that your slider pin. And somebody who's doing molds might have something to add to this. In this operation, I am going to create a new sketch up on the top face here. And I am going to hit P for project, and I'm going to actually borrow that line that is right inside of that sketch there. So if I right click, hold down my cursor here, I should be able to find that sketch line. See that line? Hang on. If we could also just hide the top plate, I guess. And P for project. There we go. Select that line so we get that endpoint there. Turn the top half on again. C for circle. and make sure we have a circle on however big we wanted to make that slider pin, like that. And now I can do I could do something like, I could use the sweep command for this. So our profile is the circle and our path is that pin there, right? And that pin is going down there. Now that pin would normally have a chamfer on it. Now what you could go ahead and do is you could actually use that pin to cut through all the other plates. So use the combine tool, select the target body as the top plate, and select the tool body would be that pin. I'm going to say I want to keep it. It's going to be a cut. Hit OK. So now if I turn everything off except the top plate, you will see that that now have an angled hole through it. That would also, we will do that to the remaining part. So we will go in and say another combine, and this time we will select our insert, and the tool body will be our slider pin. Do the same thing, keeping it, and we would actually do the same one more time to the bottom plate if we wanted to do it right. So the bottom plate, the target, or the tool body is our slider, and hold that. So what we have now is, if I turn my slider pin off, is that we kind of have cut with that one all the way through. So this is how, with all this on, this is how the mold really would be in a very rough state. in a really would be. Now, if you wanted to kind of start animating things and show things, you could. So we could go to the bottom plate and we could say that we wanted to ground it, because one of them has to be ground. And then we could say, all right, let's go ahead here and create a joint. Oh, I would create a built-in user's build joint between the bottom and the top face. Actually, let's do a build joint between the top and the pin, because they will be stuck together. Then we could go in and do a as-built joint between the bottom plate and that top wire. And instead of making it rigid, we could do a slider. We could select an edge to slide over, and they will now that will now slide up. So if I click here, see how that is going out there. But when it goes out, you probably want this one to also slide along. That is probably another video, but it can be done with utilizing a motion study. But my point is, Brian, and I hope I haven't lost anybody, my point is that when you're trying to model up a slider, at least in my experience, you're doing it as the mold is closed to figure everything out, and all the other stuff, this moving up and this sliding over. So we could probably do, if we do another build as joint, and we're selecting this to this, and we're selecting that as a slide function. Right, so this is sliding. So the whole movement now, where this is moving up, and that should move this one out too, right? And wherever that movement is, that will be more for show. And for that, I would probably just use a motion study. You could be tempted to use context sets, but that normally will slow things down. So model it up the way I did it here with the layout sketches to find out where everything should be. And then to actually get, you know, the live movements in here is more of, I call it show. Was that useful, Brian? I hope that was useful. This is just me trying to answer some of these emails. Thumbs up if you like this. Thumbs down if you don't. That's okay. Just trying to add a little bit more value. All right. That was Brian's question about doing a mold slide. Next one is from Justin, and that's a question in regards to, this is kind of dialing back to last week's, talking about the bottom up versus top down approach. And what Justin is bringing up about that is, and you can probably, if you go out to the YouTube and we search Lars, you can spell his name, and we find the channel, and we go to playlist. Here is the Ask Lives. And over here on the list, not long ago, we talked about this. Bottom up versus one of these over here are about that topic. Let's see. In here, constraint holes, all line edges. One of these, I thought. Maybe it was actually just in one of the Sunday editions. I talked about the advantages of bottom-up versus top-down approach. And what Justin is bringing up is in regards to what happens if you are changing your projected sketch and models afterwards. And could that be a risk? There's always a risk. There's always a risk. So even if you're going in and looking at Brian's here, where we used the kind of the top-down approach, and what happens if we later on want to reuse models. So you definitely, great with great power come great responsibilities, right? So you definitely got to keep in mind that using the top-down approach, like I did here, that we have one sketch that is driving everything. So what happens if you are making changes to the sketch or things, even if you sketched up in one part and brought that into another part, there could definitely be some risk with that. I will bring up that recently in Fusion, we got the derive function in here. What is a great way to bring, if you have some kind of a master model and you want to bring something forward, where if you make changes to that will not affect what happened behind it, that could be a good option. I'm not going to show that right now. That have been done in other videos. Email me if you want to dig further into that. Next one is from Jeff. Jeff writes me about modeling. He's drawing up a nightstand with a couple of drawers and trying to do some finger joints, or some, he calls it trapezoid box with finger joints. This is probably a little bit about my wheelhouse, Jeff. If you ever watched any of my other videos where I do woodwork, you will find that that I am not the best guy to that. I did do a video a long time ago about how to model a drawer with dovetails. So you can go out and look at that video. That is probably the best that I am gonna do when it comes to this, and at least until I kind of sharpen up my woodworking skills. What is a work in progress, like it is for most of us. But just so you know about that. All right, next one is a question in regards to utilizing the timeline. There was actually a picture with this one. Check this out. So this one here, talking about, this is from, who is this from? This is from Collier. So everything is great with this model, except what happens when I want to go in and put some chamfers on these holes that has been patterned. So you see here we have the timeline. You can go back to that. So actually, if we go back to that ring that we modeled up here, you will see that if we go back into this, you can grab this timeline right here and you can actually drag it back. So it's kind of the same thing you want to do. You can drag it back till wherever you were at that point, and then you can drag it forward again to get your thing in there. So if we go back here, I could attempt, I'm not sure if this is going to work, I could attempt to turn in and say I want to add a fillet here, and let's do a little bit of a fillet. So I'm adding I dragged that timeline back, I added a fillet, and now I drag it forward again, and of course it's not going to work for me. Edit that function because I selected faces. Select faces. Oh, what was I doing here? This was a pattern. Let's get out of this. Right click, edit. The objects we want to do is going to be this face, actually on the, let's just kill this for a second. You can move back on the timeline and do a this face, and then our directions of how many we want. Hit OK, and then you can drag that marker back again, and then it does work. So you can always go back in the timeline, drag that handle back, and you can add your fillet to it. So that's really what you want to do with this part. Just take this timeline down here, drag it all the way back to right there, add your fillets to it, and then drag it back again. And then you might have to go in and edit just like I did, and include them inside of that operation right there. Hope that was useful. All right, let's do one last one. This one here is from James. This I think is a good one. James sent me an email here, and he also sent a couple of pictures. So let me get that up on the screen. So what James is trying to do is that James is trying to create a crash helmet, but have a GoPro mount on it, but he wants the GoPro mount to follow the curve of the helmets. How do you do that in Fusion? There's different ways to do it, but I want to show something really cool. And this goes to anybody who 3D prints, or if you machine or whatever, you need to know about this. Let's just close these pictures down for a second. First of all, I need to get a helmet. So I want to show you a cool website if you're not familiar with it. If you go to GrabCAD, and here, and you got to log in. You got to create a login. I'll use a Lars at catcamstuff.com, my good old blog. Here, that's where you can get the free CNC Handbook. And let's search for helmets. And I'm looking here, and I see there's a SolidWorks model of there's a cricket helmet. That's kind of cool too. But there's a SolidWorks model of an Ironman. That's kind of cool. So let's download that. Click on download. It's going to be downloading. So thank you, Engineering Clayton, for providing this one. So let me just open up my downloads folder here. Right click and let's extract all that. So we get a folder here, added a JPEG. You will see all these are SolidWorks files. We can bring that into Fusion. Go into Fusion here. Open up my panel. Let's upload it. Select file. Let's go out to that downloads folder inside of that Ironman. And the trick when you're bringing anything in for SolidWorks is to make sure that you select all the different files. I'm actually going to select these. I'm going to try to select these here. All the files. It looks like there's multiple files in here. I'm not quite sure. But selecting the assembly file and all the part files. Hit open. Upload. And let Fusion bring that in. Give it a second. See what we get. Close that down. Double click. And thanks to our engineer, I got part of the helmet. There's more to it. Okay, this will work. So we have a curve here. No, this will not work. This is not good enough. It's not good enough for us. Upload. Let's just go in here again. Maybe if I select, maybe it's a multi-assembly. Let's go ahead here and select these. And let's try to select that, the biggest one, as our main assembly. Not giving credit enough to Engineer Clayton if I don't bring in his file, I feel like. Almost there. Close, let's try that. Yeah. That's much better. Cool Iron Man helmet. All right. So to ask James question here, how do we get a custom profile for this helmet? And there could be a lot of different ways to do it, but there could be a chance that the helmet design you get in is a mesh file. So I'm not gonna, even though that this is a solid model, I'm gonna skip that just because you know, why not? So what I'm gonna do is I'm gonna go into the form workspace, and I'm gonna create a offset plane. Select our plane and then hold down left mouse button, select our plane. And I'm gonna create somewhere where I think in the height, I think I wanna start my design here. So up here somewhere, I'm gonna do a flat plane on that. Go up on the top face here. And I'm just gonna draw out the foot of the mount. Like that. Okay. So now we end up having a piece here. Now I've talked about form or sculpting before. You can make this more accurate by inserting more edges. So if you went in here and you insert more edges, this will get more accurate. But there's this cool function I gotta show to you. There is in here a pull function. So if you're selecting pull, check this out. I can literally pull all these points down to that helmet surface. And the more points you have, the more accurate it's probably going to get. But now what we ended up doing with the pull function is we're getting that shape that you want to make sure that it's concave to the helmet. So if I just open up the bodies here, if I just turn the helmet off for a second, you will see that I have kind of like all those points are lined up with that. And now I could go in and do something like a thicken to this. And we could add some thickness to it. Maybe just make it like a couple of millimeters thick. And that will now be a solid body that is laying on that surface. And again, the more points you have, the more accurate it's going to get. You can see if we zoom in that it's not right here, it's missing a little bit. So you probably want to be a little bit finer than I just did. But this is really cool because this is now can now be a solid body that you can work with as your GoPro mount. So with that, we got an Iron Man helmet. We have done some mold sliders. We have done some weaponry almost, some milling, some bicycle frames, some surfacing versus solid modeling. We did a ring here, and also something I can't even pronounce. That, my friends, is going to end this, the 8th of these Sunday editions live stream. I really appreciate it. It's just me trying to answer some of my emails.